Good morning, class. Today we're going to take notes on 8.3 geometric sequences. So get ready for notes. Also, while you're getting ready for notes and writing this down, I just want you to make sure you know you can stop this video at any time. Just raise your hand and let them know, hey, can you pause that for a moment? And then also make sure you're answering my questions when I'm asking you. Alright, so 8.3 is geometric sequences. A geometric sequence is a sequence with a constant multiplier and we're going to call that constant multiplier R. Now sometimes it also will be called a constant ratio, or a constant ratio, and that also will be still your R. Alright, again with sequences we have two types of formulas. The first type of formula is your recursive. In a recursive formula, what do we always need to know in your recursive formula? Remember, it recurs more than once, so we need to have two things. We always need to have the previous term. So on a side note, and you can write this down if you want, or you can just do a side note with me. Remember, this is what we're thinking. How did we denote the previous term in an arithmetic sequence? What was that? A little louder. Yes, it was a to the n minus 1. And a is because of arithmetic. So how do you think you denote the previous term of your geometric? Yes, g sub n minus 1. So the formula for your recursive formula for your geometric sequence would be g sub n is equal to r, which is your constant ratio still, and then your g to the n minus 1. And just know that r cannot be 0, because if r is 0, it's not going to be a sequence, it's just going to always equal 0. So again, your g sub n is going to be your nth term, whatever term you're finding. Your r is your constant multiplier, or your constant ratio. Your g n minus 1 is your previous term. Alright, so that's your recursive formula. Alright. So your explicit formula is G sub n is equal to G1 times your R raised to the n minus 1. So your n is still the term we're finding, your R is your constant multiplier, and G1, what do you think G1 is? Yes, your first term. Alright, anybody need to stop the video? Raise your hand. Alright, example 1. Alright, first part we're going to write the first 4 terms of the geometric sequence which has G1 is 4 and R equals 2. So, what is our first term, class? Yes, 4. What does this mean? What do we have to do with the 2? We have to multiply it to 4. So our next term is, class, what's the next term? Yes, 8. A little louder, what's the next one? 16. And the whole class now, what's the next one? 32. Yes, you're simply multiplying 2 each time. But if I wanted to keep doing this, if I say, well, find the 20th term, remember you'd have to find every single one of them. And that's the same as when we have our recursive formula. B, it says now write the recursive formula. What would it look like? So write a recursive formula. Alright, so to write your recursive formula, it, remember, is your Gn is equal to your R times your G to the n minus 1. And remember that n minus 1 is a subnote. So all we have to do is plug in our R, and then it would be the end of the formula. So it's G to the n is equal to 2 times your G to the n minus 1. Again, if I wanted the 20th term, I'd have to find the 19th, the 18th, because that needs the previous term. Alright, C, we're going to write an explicit formula and find the 10th term. Alright, so remember your explicit formula is G sub n is equal to G1 times your R raised to the n minus 1. So we have G sub n is equal to, what's my first term? What was my first term, class? 4 times R, what was my R? 2 to the n minus 1. So that is my explicit formula. Now, how do I find the 10th term? 10th term is you simply plug in 10 for your n. Now, also class, remember that you cannot multiply. Why can I not multiply this together and just say 8? Yes, because of order of operations would tell me that we have to do this first, then multiply it by your 4. So your formula has to stay like this. So my 10th term would be g, I'm going to move it up so the back row can see. We have g sub 10 is equal to 4 times 2 to the 10 minus 1. So plug that into your calculator and make sure you get the right one. Alright class, hopefully you got 2048. That was a funky 4, sorry about that. Alright. Anybody need the video stopped? Please raise your hand. Alright, example 2. A ball is dropped from a height of 60 feet. And it bounces 80% of its previous height after each bounce. Alright, so a ball is dropped from a height of 60 feet and it bounces 80% of its height after each bounce. Alright, we are going to let h sub n be the height after n bounces. So we're going to let h sub n be the height after n bounces. Alright, so just so we can get a visual of what that means that we're going to have a height, it's going to be dropped from a height of 60, and then it's going to drop down, and then it's going to bounce up, and then that's going to be, this height is going to be 80% of the previous one, and it's going to bounce again, and then that's going to be 80% of this one, and then it's going to bounce again and keep going like that, right? And it says let h sub n be the height after the n bounce, right? So after it bounces, this is your first height. So this one is your first height, and then this is your second height. But sometimes they don't only say that this is your second height, they could say that this one, so this one would be on the first, so this one's on the first one, so they sometimes say that that's on the first bounce, and then this one would be on the second one, or after the first. And I will tell you that they use on and after for problems. Alright, here we go. So we are going to do 3 things. The first thing, A, we're going to write an explicit formula. B, we're going to find the height of the ball on the fifth bounce. And the last thing we're going to do is C, we're going to find the height after the fifth bounce. When you guys get your homework in a little bit, actually the last one, I think it's the last problem on it, there's a bouncing ball problem. I actually want you to try to find the on and the after. I know on your paper it's crossed out the after and it just says on, but I actually want you to try to find both of them. So try to find both answers. Alright, so the first one, the explicit formula. Alright, so the first thing that we're going to do is find your explicit formula. So remember, your explicit formula is G to the N is equal to your G1 R to the N minus 1. Now, G1 is my, yes, first height. So I'm going to pull it up here for a second. I'll bring it down in a sec. But that means it's not this one, but it's my first height after, because it says after the bounce is my first height. So it's gonna, this is my first height, so I have to find out what this height is, right? Which is, how do I find this? It is 80% of the 60, right? So I'm gonna go 60 times 0.8. So I have G1 is equal to my 60 times my 0.8. So that gives you 48. So now we're going to plug it back in. So we have G N is equal to 48, and R, what is the constant ratio? What is the one that's going to, every single time, it's going to be multiplied by 0.8. Yep, so it's 0.8 raised to the N minus 1. So that's your answer. Then B says to find the height of the ball on the fifth. So we simply plug in 5 there. So we have G to the 5, the fifth bounce, is equal to my 48 times 0.8 to the 5 minus 1. So plug that into your calculator and see what you get. Did you guys get 19.66? Hope so. And the last one, C, it says to find the one after the fifth bounce. So that means, I'm going to bring it back up here for a second. That means if this was the fifth bounce, right, and that was the height of it, it wants the one after it. So the one after it would be the sixth bounce, or the sixth height. So it would be G to the 6 is equal to your 48 times your 0.8 raised to the 6 minus 1. So now plug that into your calculator and you get 15.7. Very good. Alright, that's the end of notes. So if you have any questions, you can ask me tomorrow, but try to do as much of the worksheet as possible. And also try the one that has the bouncing ball, try to find on that bounce and the one after that bounce. So try to find both of those answers. Alright, see you tomorrow.